our first postulate, which is written, the ruler postulate with the coordinates and distance filled in. Our first obvious postulate, let's see, should be then the distance. If we know that b is at 4.5, a is at 1, what's the distance of AB? 3.5. AB, you can say 1 minus 4.5. The absolute value of a negative number is always positive. So the distance has to be 3. Oh, come on, that word. Should be 3.5. Oh, let's see. Between is a very distinct word that we're going to have in this class. Between it has the same meaning that you think it should. It should be in the same sense between 2 points. If a point is between two others, then it's got to fall in the middle somewhere. But it also has to be very specific. For 2 points to be between, for a point to be between, then I spell things. Between two others, they all must be collinear. As long as B is somewhere in between, somewhere in the middle and on the same line. If we have, say, points about D and F, what are some ways we could draw E such that it's not between them? Christine, what's one way?
You could put it like on the other side of F, so it's not.
Okay, we could throw E over here. That's definitely not between. That defies our convention of what between should be in the first place. Okay.
You could put it off the line.
You could put it like off the line. Would be another spot such that it's not between. I can think of like one other place that I could put it such that it's not between. Yeah, the other side of say D, like up here. Over here, it's clearly not between, and it's definitely not between if it's not collinear. Is the major point from this definition. Does that make sense? Oh, come on, Pen. Pen back.
Pause. You just started it again.
Our second postulate is another obvious statement, if we think about it. It's called the segment addition postulate. We'll be using this often. It says that if B is in between, A and C, then the following must be true. Then if you take the segment starting at one endpoint and go to B, the one that's between, and then you take that in-between point and go to the other endpoint, then what should that segment be the same length as? The full segment, AC. That's all the segment addition postulate says. It says that the sum of the parts should be equal to the whole thing, is what the segment addition postulate says. It also works in the reverse. So that if you know that this relationship is true, that you have a sum of parts that should fill up an entire line segment, it fills up an entire line segment. If you know that you have this equation, you know that this relationship is true, that you can claim that the point that's shared, in this case B, has to be between. Must be between the two segments. Is that we should be able to, from that, use this to actually find some pieces. We should be able to use this to do some calculations. So in particular, if you have a diagram like this, we have the library, is at point L, and then farther down the road, 12 miles is the stadium. And then farther down the road, somewhere else, is the museum. And we know that the full distance, all the way from the library to the end, is 41 miles. Then we should be able to know something about the relationship of what the length is from the stadium to the museum. In case you can't read that, this first segment here is 12. The full segment is 41. And I'm asking you to find what is the distance from the stadium to the museum. The segment addition postulate says that you should be able to find that distance. What is the distance? 29 miles. Algebraically, you could set up an equation. You could say from the segment addition postulate that first part plus the second part, which we don't know, has to be equal to the whole thing. And you can solve that equation, which most of you did in your head, and you end up with the same answer. That distance has to be 29 miles. The segment addition postulate is not supposed to be a mystery thing. It's a common sense thing. It's if you have a line and you break it into two parts, then if you add the two parts together, it's the whole length. The second algebra example. I would start by trying to draw a picture. Let's try to understand what this picture should look like. Point B is between A and C. So let's draw a sketch. If B is between A and C, let's get an idea what this picture should probably look like. There's an A, and C is somewhere down here. B is in the middle somewhere. I'll draw it like right here, because it might not be right in the middle. It might not be in the midpoint. It might be somewhere else. Use the given information to write an equation in terms of x. So let's see, what do we know? We know that AB is 14. So what part is 14? This part right here, from A to B. BC, from B to C, is, variables here. 3x minus 4. And then AC, the entire thing, is 4x plus 4. Segment addition postulate says that first part plus second part should equal the whole. So what I want you to do right now is take this drawing, set yourself up an equation, and do three things. Solve for x, then use x to go back and find what the length of BC and what the length of AC should be. Alright, so you should have, using the segment addition postulate, taken AB as 14, taken AB, which is 14, added it to the length of BC, which is 3x minus 4, and gotten the length of the entire segment, which is 4x plus 4, should be the equation you came up with. From that equation, now we can use Algebra 1 skills. We can combine 14 and negative 4 to get 10. And then you could get all the x's on one side and all the constants on the other. I'm going to subtract 3x from the left, subtract 4 from the right, and get 6 is x. So now that you know x is 6, now we can plug them back in, and you should get lengths of BC is 14, and AC is 28.
So B was in the middle.
So it ended up being, in this case, B was exactly in the middle. For letter C, the example problem, set up something very similar. Only thing, instead of A, B, and C, you have T, V, and W. The same principle applies. Take the parts. The first chunk is 3x. The second chunk is x plus 8. and that should be equal to the entire length, which is 32. The sum of the parts should equal the whole. 3x plus x plus 8 equals 32. You could combine some like terms. 3x plus 1x is 4x's. Subtract 8, divide by 4, and you end up with x is also 6 again. And if x is 6, plugging in to find the length of VW, that means VW is 6 plus 8, which puts it at 14. Here's the definition of what congruent segments is, and congruent in particular. Congruent segments are segments that are the same length. If two segments have the same length, then they're congruent. We're going to use the word congruent over and over and over again this year. Congruent means this basically a copy of. It could be rotated, it could be flipped, but it has to have the same shape and the same lengths. Since lines all have the same shape, then the only thing we can look at is the length. The symbol for congruent, which you'll see a lot, is an equal sign with what's called a tilde over top, or a squiggly line. This is the symbol for congruent. I'll put it in parentheses so you know it's a symbol. It's a symbol for congruent. Okay? So if you need to find if two segments are congruent, find their lengths and then compare their lengths. For today and for this section, we're going to give you segments that are all on the grid lines. We're not going to have diagonal segments in this section. We'll look at how to compare lengths of points or of segments that are angled that you can't just count. We'll see something that will help. We'll get a formula to help you out with that. But for today and for today's homework, you'll notice that all the segments will be on the grid lines. Okay. Example 3. Finish example 3. Plot those points. Count the boxes to find out what the lengths are, and then decide if they're congruent or not. Okay. When you're finished with that, I'll get the homework thrown up, and we'll have probably about 10 minutes or so to get working on it. Here's your answer. The length should be what? 1, 2, 3, 4, 5 for HG. 1, 2, 3, 4, 5 for FG. So then FG is congruent to HJ. They're the same length.